Alright everyone, this is Mr. Harding. I am going to take you guys through the Unit 1 review, hopefully going over all of the major topics and explaining some of these questions to the best way possible so that if you are working on this on your own or just trying to refresh your skills through the Unit 1 content, hopefully this will help. So the first 4 questions you can see all solving equations. First one, you have an equation with variables on both sides, so you need to make sure that you can get those two variables together. I know some people like to draw this line through their equation just to let them know I gotta get these variables on the same side, and what I mean by side is side of the equation there. So that's why a lot of people like to draw that line. So personally, I always like to make sure that my variable is positive. I really don't care if it's on the left side or the right side. I just want it to be a positive, have a positive coefficient. So I'll subtract that 2x over, 1 comes down, and that's going to be equal to a -5. Because I chose to take my variables to the left, that means I've got to take my constants to the right. So I'm going to have to subtract 1 here. Because remember, the other thing that we talked about with solving equations is whatever you do to one side, you have to do to the other. And in order to take something to the other side, you have to do the opposite operation. So up here, we're adding 1. The opposite of adding would be to subtract 1, which is why I had to do that to take that value over to the other side. At this last step, I can get rid of the coefficient in front of x by dividing by 3, and I'll get my answer, x equals -2. And I'll do this for the first one, but I won't do this every other one. Remember, you can check answers to all equations by taking your answer, plugging it back in for your variables. So we would have 5 times by a -2, and then plus 1. So that's going to give me a -10 plus 1 gives me a -9. So I got to make sure when I plug it into the other side, I also get a -9. So I have a 2 times by a -2 minus 5. Well, 2 times the -2 is a -4. -4 minus 5 is a -9, and so that's a good sign. That means I definitely got the right answer. So again, I'm not going to do that every single time, but just one last time for you to go over this. Remember, you can always check your answers when solving an equation. Plug that variable, your answer for the variable, back in every single place you find that variable. Some equations, like you look at number 3, some equations only have one variable, but maybe you have equations that have 2 variables, like we do with 1, 2, and 4. And there's definitely other times where you might see more than 2 variables. So you just got to plug it in for every single variable. Starting off number 2, I like to simplify both sides, and you should probably do the same. So again, you can draw this line. This will probably be the last question I draw the line for, but you can draw that line through the equal sign. That means I've got to simplify both sides of that, so left side and right side. So on the left side here, it's almost like I got a -1 out front of the parentheses here, this quantity. So I'll start by distributing, something else you definitely should have talked about in your class. So I'm going to distribute that -1, but remember, distributing is multiplication across addition inside of parentheses here. So I would not distribute this to the 5 that is clearly outside of the parentheses. So I'm just going to add that 5 down. On the right side, I would also start by distributing, and I get that -2x and the -6. At this point, it looks a lot like number 1. I do have this one step here where I can collect those together. It might just make it a little bit easier to move from side to side. But I actually didn't have to do that. There are other ways to go about that problem. But I combine them, and now definitely what I have right here looks a lot like number 1. We've got variables on both sides, constants on both sides. I got to try to find out what x is. Again, my personal goal, I always like when the coefficient in front of my variable is positive. So I'm actually going to add 4x this time to the right, because that'll give me a positive variable. This is another thing I'm going to start doing just to kind of save time, and this is how you can start to save time on quizzes and tests and things like that. I'm going to do more than one step. I know I can add my variables together here, but I can also add my constants at the same time, because those two things are not like terms, and therefore you wouldn't be able to add them together. So I'm adding my 6 to the left, I added my 4x to the right, and that's going to end up giving me a 6 plus 6, which is a 12. And then when I add my two variables together, a positive 2x, which I can then divide, and I can find my answer. Now, I know a lot of you think the variable has to be on the left side. That is not true. If you want to, you can rewrite it, but it means the same thing. 6 being equal to x, or x being equal to 6, is the exact same thing. Number 3 is a little bit trickier. I always tell my students you got to work outside in. So anything closest to the variable that's on the inside, you got to deal with that stuff last. There are ways to solve this equation a different way. For example, you could multiply by 5, but what most people do is they only multiply the 7 by 5. And technically, if you want to multiply by 5 right now, how this problem sits, you'd also have to multiply the 3 by 5. And a lot of students just forget about that. A lot of people in general, not even students, a lot of people just forget about that. So to make your life easier, let's just subtract the 3 first. And now, when you go and you multiply by 5, you only have one other thing to multiply by. You multiply that 4 by 5 to get 20. And then again, remember, you can always check your answer. That seems very large, but that's because you're going to take that number and you're going to divide by 5 first. And then you'll add 3 to it, and you'll get your answer of 7. So that definitely works out for you. Number 4, last one here, solving equations. We're just going to, again, start by simplifying both sides. So I'm going to distribute my 4 here. Gives me 8x minus 12. Now I've got variables on both sides, constants on both sides, so I need to collect those. So what you notice here is it's the same coefficient with the same variable, which this is where you can start to move even quicker through things. Hopefully a lot of you notice those two things are going to cancel out. No matter what x is, when I multiply by 8, this quantity is going to be the same as that quantity. They cancel each other out. Now, if you don't like thinking about it that way, you can still work through this, subtract the 8x, subtract the 8x. But those two things are going to cancel each other out, and that's going to leave you with a negative 12 is equal to 15, which you guys all know that that's not true. And since that's not true, that means there is no solution. So you definitely just write the word, or remember that fancy symbol we have, the circle with a line through it. That means no solution. What that means is there is no number in the world that you can plug in for x to make the left side equal to the right side. It's just not possible. In other words, there is no solution. All right, last one on this first page here, number 5. We're starting to look at a word problem, and I know you looked at a couple here in this unit. So I always just like to break it down by underlining important things. We have a sum of 379. That means I'm going to add some things together to get 379. Specifically in this question, what I'm adding together are 2 pages that face each other. Think about how a book works. When you have 2 pages, I know a lot of you guys don't read anymore. When you have a book, you have one on one page, next page is 2, and then 3, and then 4, and then 5, and then 6, or 11 and 12, right? Page numbers are consecutive integers. So if I don't know what page I'm on, but I do know the 2 pages add together to give me 379, what I do know is if this is page X, because I have no idea what it is, then the page next to it would be X plus 1, right? Don't I just take whatever X is and add 1 to it to get the next number that's facing it in a book? So I know the first page plus the second page, that sum is equal to 379. So look, and it looks like C is my answer, and that's definitely true. If I remove those parentheses, which technically are not necessary, I would have the same thing as letter C. And I don't even have to solve it. A really nice question. Number 6, another word problem, but even a little bit harder. There's no multiple choice here. And as you read number 6, you say, even though you could guess and check this one, do it algebraically. So what I mean by algebraically, use variables, write equations, solve equations. So you've got three people here, Larry, Barry, and Harry, all have different ages. That actually, it's kind of like a fact thrown in there that doesn't seem important, but it is. Okay? The sum, there we go again with sum, is 49. So if I add Larry, I always like to solve equations by writing them out first. I take Larry's age, and I add Barry's age, and I add Harry's age. That should equal 49. Well, I can't add Larry, Barry, and Harry if I don't know what they are, so I need to use variables and the information that's about to come to represent this as an equation. Barry is 5 years older than Larry, so I know something about Barry. He's 5 more than Larry. So for example, if Larry's 10, Barry's 15. Harry is twice as old, so 2 times as old as Larry. So again, if Larry is 10, Harry would be 20. So now you can see I changed Barry's name into information revolving Larry. I changed Harry's name into information revolving Larry. So now everything's written in terms of Larry. In other words, I can let Larry's age equal X, and now I can set up an equation. Larry's age is X. Barry's age is 5 years plus X. And Harry's age is 2 times X. And now I have an equation, which this is the only thing you've learned so far this year. One equation, one variable. I could have an X, a Y, and a Z, but it would be really difficult to solve. A, you haven't learned how to do that yet, and B, as you start to have more variables than equations, things start to get really difficult. In a couple of chapters, we'll start to look at 2 variables, 2 equations. But as long as I have the same amount of variables as I have equations, it's possible. And we have methods for that. But when I start to have more variables than equations, it's difficult to do. And you almost always have to guess and check. So let's collect our like terms. We've got an x, and a 2x. That gives me 4 x's plus a 5 is equal to 49. Subtract that 5 to the other side. This is why we spent so much time solving equations. Divide by 4. I find out what x is. Remember, and that's why I like to write it down, x is Larry's age. So Larry is 11. Barry is 5 more than that, so that means Barry would be 16. Harry is twice that. That means Harry is 22. Together, 22 plus 16 is 38, plus 11 is 49, so I know I got the right answer. Now we start to talk about some inequalities. So number 7, write an inequality statement for each graph below. Remember, inequality statement, less than or equal to, greater than or equal to. You might have to use words and or for a compound inequality, right? These arrows shading in opposite directions. There's no way I can say that nicely all at once. I'm going to have to say x is less than -4, and I know it's less than because of the open circle. Or my other possible answers are when x is greater than or equal to, solid circle, 3. There's your answer for letter A. For letter B, my answers are in between 2 numbers. And that's the key word there, in between. Whenever I see that, I like to put my variable in between 2 inequality signs. X represents all my possible answers. All of my possible answers are between -7 and -1, but both of those numbers are included, so you see how I'm going to make my less than signs less than or equal to. Okay? Now there's your answer to letter B. Number 8, last one here on this page. How could I solve this inequality? We did equations first because we didn't have to worry about all this number line nonsense. But solving an inequality is the exact same way. Still got to get rid of the constants to the other side. And then we want to isolate the variable. Now, one trick with inequalities. When we divide by a negative, I need to flip my sign. See what happened there? My sign flipped from a less than or equal to greater than or equal to. So, x is greater than or equal to 6. and that would be letter D at the bottom. More inequalities on the next page, number 9. Which one of these matches that statement? What I would do first is I would take this and let's just write it out, kind of like what we did on the page prior. I'm at a -3. X, which is all of my answers are greater than or equal to -3. So that's what I'm looking for. I have to solve these until I get to that. But the reason why I like doing this is because, look at this, look at my answers. I know that it's definitely not A or C, and I don't even have to spend time with those because look at their inequality signs. Look at my inequality sign. Now the one thing you do have to be careful about, I know a lot of people are like, oh, it's obviously D. And in this question, yeah, maybe you think it's obviously D, but in most questions, remember how on the page prior we flipped that sign because we divided by a negative? So you don't just always want to match up based on the sign, because remember, these signs could flip. What if this was a -2x plus 5? Well, I would have subtracted the 5 over, and then I would have divided by a negative, and that would have flipped my sign. So you can't just always pick just based on the sign. I would start with this one because obviously the signs match up. So let's solve this just to double check. Subtract the 5 to the other side. I get 2x is greater than or equal to -6. I can divide by the 2, and it does in fact match up, which means D is my answer. But again, you guys know when you divide or multiply by a negative, that sign could easily end up flipping. So just because it's greater than or equal to here doesn't mean it will be greater than or equal to when you start the problem. All right, compound inequality. Remember how we solved these. Our goal still to get x by itself. X is all of my possible answers, but right now x is disguised with this 2 and this 3, so I got to try to remove those. Just like solving an equation. If that was my equation right there, how would I solve that, right? I'd have to get rid of the 2 first and then the 3. Same thing. I know it's a little weird because it's written on both sides. So what we do is whatever you do to one side, also have to do to the other value, because these are possible solutions. So we get rid of that 2. 5 minus 2 is 3. 14 minus 2 is 12. I can still try to isolate x, so it's definitely by itself, divided by 3. Now I get x by itself in between two numbers, so I look for that exact answer, and I get D again. Now you're going to start to solve some on your own, which means you're going to have to make your own number line. So, compound inequality, when it's the word or, I definitely like to draw my line here. This is two different questions almost. Let's just solve the one on the left first by subtracting the 3. Now divide by the 2. I get one statement here. Or, let's solve this one by adding the 7 to the other side. Alright, two possible answers. The word or means both of them have to be represented in my solution. I always ask my students, draw a 0 first. Draw what I call the numbers of interest, so that -2 and this +3. +3 needs a solid circle. The -2 needs an open circle. And now let's make sure that we shade the right way. Where would my answers be greater than 3? Well, that would be numbers like 4, 5, 6, 7, and so on. So that's up. Where would my numbers be less than a -2? Well, then that means the numbers have to be even more negative. So that means to the left, and I would end up with an answer solution that looks like that. We're almost done. I know these videos can get long, so again, if you're kind of following along, just jump to the questions that you want. Okay. This is the second biggest review. Unit 2 is the biggest. So they are going to take some time, but other than that, the reviews aren't as long. And again, just jump through to whatever you need to see. So like if you don't need to see another inequality, skip it. Go to the word problems or absolute value. I know that was a big topic in this unit. Another compound inequality, word and. Again, I like to just kind of separate these, especially when they're written separate to begin with, and just solve them on their own. Here's the one instance where maybe you don't want to add the x because you might start to confuse yourself. Again, I told you before, I always like when the variable is positive. But because there's only one variable here, I might not be able to avoid that in a way that makes sense to most people. So I'm going to leave the negative x where it's at. I'll subtract that 5 to the other side. Don't forget I've got to get rid of the negative sign in front of the x by dividing by a -1. And then on top of that, don't forget that our sign flips when we do so. So we got x is less than 9, and let's subtract the 1 to the other side. And then we can divide by a -6, which again means my sign is going to flip. So it's greater than -4 and less than 9. So think about this. Where do I have numbers that are greater than -4 and less than 9? Well, let's at least start with this. Put 0 in the middle. Where would 9 be? Where would -4 be? Let's make sure that we have the appropriate circles. I need to be less than 9 and greater than -4. That means my answers are in between -4 and +9. So all my answers are in between those two. So this is what I like to do, but you can still draw your arrows towards each other. It doesn't make a difference. Just make sure it's clear that the answers are in between those two numbers. All right, a word problem with inequalities. So just like our other word problems, just read carefully. Sort your information, things like that, okay? Just read carefully. So they have $1,000 to spend. It's $185 on a new, looks like that has a misprint. That should be a new bat. New baseballs cost $4 each. Each is a key word here. I want to know how many baseballs I can purchase. Well, I don't know how many, but I know they're $4 each. So that would be like 4B. The bat, $185, and they only bought one of them, so that's why I just had that plus 185. And that's my $1,000 that I was able to spend. So that's where this comes from. What statement's true? Well, I'd solve this. So we take our 1,000 and we subtract 185. So that's going to give you 815. We would then divide that by 4, and that's going to give you 203.75. So almost 204 baseballs. But not quite. I don't have the money, and the number of baseballs that I get has to be less than or equal to 203.75. So can they purchase 204 baseballs? Unfortunately, no. They wouldn't have enough money. They're very close, but they can't. Is the minimum number of baseballs 185? Well, no, they don't have to purchase any. Less money. No, that's not true. Is the maximum 185? No, to me it seems like the maximum is 203. So that's not true, which means it has to be letter D, but let's just double check. Can they purchase 195 new baseballs? Yes. This number is neither the maximum nor the minimum? Yeah, it's definitely true. The minimum is 0. The maximum is 203. So we're good to go. All right, we only have a couple of questions left, but they are probably the hardest ones, so we've got some absolute value. What I also like to do is treat it like it's an equation, regular equation. But instead of this absolute value stuff, if I were to replace that with just a variable right now, what would you do first? Well, you'd probably add the 3 to the other side. So, same thing over here. Let's add the 3 to the other side and get the absolute value expression isolated. And now I can split it up. Why I'm splitting it up is because 2x minus 7 might be equal to 21, but remember, absolute value almost always has two answers because 2x minus 7 could also be equal to a negative 21, because isn't the absolute value of negative 21 also equal to 21, which is what I'm looking for here? So we have to include both the positive and the negative answer. Now I can start to solve these both by doing similar things, adding that 7 and then dividing by 2, add the 7 and then divide by 2, and I get my two answers, negative 7 and 14. And they are just both answers, so negative 7 and 14. Last page here, another absolute value question. Solve for x, graph it on the number line, and if your final answer can be written the fancy way, meaning if you can stick the x in between two numbers, let's do so. Okay, so this is already isolated. Let's split it up. 2x minus 5 is less than 11. And then you might be thinking to yourself, well, what word do I use? And, or. Well, think about this. Less than 11. If I look on a number line, numbers that have a distance from 0, because that's what absolute value means, that's less than 11. Well, here's 11. Less than it would be this way. Negative 11 has the same distance from 0 as 11 does, and the distance less than that would be towards 0. So that, to me, looks like we've got a little and question going on here. So I'm going to replace that question mark with the word and. 2x minus 5, we flip the sign and flip the value, right? Isn't that what we looked at up here? We flipped the sign to greater than rather than less than, and I flipped the value to a negative 11. Now I solve both sides. I get x is less than 8, and I add the 5 over to the other side. X is greater than a negative 3. So, and means they should be shaded towards each other. And also means, as I look at this, right, here's 8, here's negative 3. Look at where my answers are. They are in between. So I can write this the fancy way. So I should. X is in between a negative 3 and a positive 8. So that would be the fancy way to write this. All right, we just had 3 more types of questions. Simplifying square roots. Remember, don't just plug this into your calculator. What you're looking for is what numbers multiply to give you 98. So a 2 and a 49. I like to tell my students, keep your things organized. So I write that square root sign each step. There were 2 ways to do this at this point. I think you guys are smart enough. I like to think of perfect squares. That's a 7 times 7. So if I have a perfect square, that's going to simplify because I can take the square root of it. So I'm going to take the square root of 49, which is equal to 7. I'll take that number outside. The 2 is not a perfect square, nor does it have any other factors, so that stays inside. I know there are other fancy tricks and techniques. A lot of people like to do this, where they split that up and rewrite it. And now I have a 2 times a 7 times a 7, and I can take these out. And that's definitely true, but that's more of like a trick. This is why this happens. You're taking the square root of something. You can take the square root of a perfect square. 49 is a perfect square. The square root of that is 7. And so I can just jump right to this nice answer here. Number 16 was what's known as a literal equation, so multiple variables, but you're just focusing on one. I want to get L by itself. Work outside in. That means I've got to get rid of the 2W, take it to the other side. I'm starting to get L by itself, but there's still a 2 in front of it. Let's divide by that 2. Different ways to write this answer. I'm okay with you just writing it like this, because I can't simplify the coefficient in front of p, which is a 1. But I wouldn't be surprised if some of your teachers at least show you or maybe ask you to write it like this. You could call that 1/2 of p minus w. And the reason I was able to do that is because when you have an answer written this way, that means p is being divided by 2 and the 2w is being divided by 2. Well, p divided by 2, again, there's technically a 1 out front, so that's almost half of p. And then 2w divided by 2, well, the 2's cancel, and that's where you're left with w. So, I mean, personally, I do think this looks a little nicer. It works out a nice way. It doesn't always, and so sometimes this is the nicer looking answer. They are both equivalent, so it really does depend on your preference, or maybe if your teacher has a preference. Last question. We just talked about cross multiplying. It's a really good skill, especially working with ratios. So we're going to cross multiply. It means 13 times x, and then 6 times 78. So that'll be 468. And then I guess I couldn't go through the whole thing without a calculator this morning. I am going to need one for that. I don't know how many times 13 goes into 468. Although, I guess I could take a guess. That would be, well, 30 times is going to be 390. And then we need another 78. So I'm going to guess 36. Oh, there we go. So 468 divided by 13 is a 36, which would be your answer to the last question of our review. So again, I know it took a long time, but that's because we went through every single question. Hopefully you watched what you were looking for. Maybe you just wanted to go through every question. But again, on these reviews, which can take a long time, just go to the questions that you need to. Obviously, I'm going to go in order, so if you need to see number 10 and there's 17 questions, it's probably over halfway through the video. So things like that, you can jump around. All right, good luck on your Unit 1 test, and if you need anything else, just definitely ask your teacher.